Firefighting drone using fire suppressant balls. Abstract as the development in innovation and improvement in smart cities, the administrations for firefighting have become even more challenging to adapt the idea of smart cities. One of the most common difficulties which firemen are confronting is to reach at the highest levels of multi-floor structures, and even to reach the firemen requires weighty and bulky hardware to arrive at highest levels, which they occasionally neglect to follow through on schedule because of enormous urban communities' traffic. The proposed answer for this worldwide issue is utilizing firefighting automated airborne vehicle, UAV, to arrive at the highest levels quick and productively. It can likewise offer a superior vision to the firefighting group and proposing the use of fire suppressant ball. These balls dropped into the flame, where it initiates and spread a dry fire extinguishing powder. These fire suppressant balls put off A, B or C class fires. In this paper, an idea for a firefighting unmanned vehicle, that is, a drone, is used with shooting as well as dropping mechanisms. The other component of drone involves using laser for range detection. A camera is also integrated to increase the capability of drone with night vision that can give accommodating guide to firemen. The thermal imaging camera could be utilized to detect the presence of fire. It likewise demonstrates the presence of individuals who were caught in the structures, and they can be seen as effectively even within the sight of smoke, where the firefighters could not operate directly. Keywords: UAV, unmanned vehicle, FCB, flight controller board, fire suppressant ball, Arduino, RF transmitter. Introduction. Drones are essentially flying unmanned vehicles which can be controlled by a trained professional or made to take flights independently with the help of softwares involving different programming languages in their embedded system, PLC. The drones need to become savvy and intelligent to upgrade current industrial processes, augment their utility, and can be broadly settled in later factories. This innovation offers different applications not just in the field of aerial reconnaissance and checking, yet in addition firefighting tasks. On August 4, 2016, National Geographic used ping-pong-size fire suppressant balls. They used a drone to control fire in the forest, where a small fire can lead to big disaster because of dry wood on the forest land. This helped firefighters who try to stop these small-scale fires, which eventually prevented the big forest fires. As there are huge innovation upgrades in trend, from small-scale machines to big construction machines, independent companies to some large corporations, the firefighting administrations are also using new technologies to increase their efficiency in stopping fire, to reaching on time to situation analysis in case of fire. The applications of UAV have already expanded in the last couple of years. UAVs are the essential part of this century, from traffic to examine the solar panel establishment. With the improvement of savvy urban areas, these unmanned vehicles are utilized in a broad scope of uses. They are very much adaptable in doing tasks that are very troublesome or risky for people to perform. A few investigations on UAV were done by some firefighters to investigate how cost-effective is using UAV in case of fire. The drones, UAVs, used by firemen mostly center around investigating the place of incidents with a thermal vision camera, but they don't have an independent system for fire dousing purposes. Different researchers thought of water tank arrangement in drone, or by using a pipe from ground and using drone to spray water, but one of the biggest challenges was stability of drone. Fire suppressant balls, which are used to stop fire, can be utilized to restrict the further spread of blazes and resolve the stability problems, when handled accurately. In the 19th century, the containers made from glass were used, in which fire suppressant fluids was stored and were used to stop fire when required. But, over the time, glass ball turned out to be less popular to numerous clients. The use of glass containers for fire extinguishing application was made out of order, such that glass was no longer employed, yet it is underlying with froth packaging and use of PVC come into place. One of the features of PVC was that it can counters and responds to hotness or fire rapidly, which eventually triggers embedded systems inside the PVC unit to react quickly and scatter the dry synthetic fire suppressant filled inside of ball. In order to initiate, these fireballs should be thrown, tossed, or must keep in close range to the fire. Therefore, at that point, it activates or triggers, and spreads out the dry fire suppressant powder. In this paper, we are proposing an idea for using a drone UAV with a dropping and shooting mechanism. The drone throws the fire suppressant ball that assists firemen to diminish the further spread of fire in risky situations. This paper gives a theoretical approach to assist firemen with stopping the fire and given real-time surveillance of an area. The overall goals are planning and fostering an automated airborne vehicle, UAV, to help firemen and people in killing fire. 2. System requirements. The proposed drone in this paper is utilizing the hexacopter configuration. With this configuration, the required amount of thrust will be delivered by the brushless DC motors having defined propellers, explained in section System Requirements. When the quadcopter arrangement is utilized, one of the problems is the size of every propeller must be enlarged, so that it can deliver similar thrust as in hexacopter configuration. A fire suppressant balls. The development of the fire suppressant ball is a progressive innovation which undeniably furthers the firefighting applications than the conventional fire extinguishers. The use of these fireballs is easy and gives full-time protection as they are self-triggered, when in close proximity to fire without any human interventions. Also, weight of the ball plays a crucial role as it comprises the payload of drone. There is different size of balls available ranging from 400 gm to 1.5 kgs. For this paper, we are using the 400 gm balls because of their compact size, which enables the drone to carry more balls at same time, as well as their fire extinguishing area of approximate 60 square centimeters. Figure 1, Mini, 400 gm, fire suppressant ball 2. B. Thermal imaging camera and its battery. The camera UniCH5203 is an innovative mix of 3-pivot gimbal, thermal imaging, and low-light camera. The coordinated 3-hub gimbal can be endlessly pivoted 360 degrees. This mechanism gives an uninterruptedly turning 360 degrees all-round view without moving the drone. Thermal imaging is important for applications, for example, solar panel review, fire administrations, search and salvage, and real estate development and evaluation. The camera conveys thermal pictures, but at the same time can do surveillance with the residual light camera in nightfall or in dim environmental situations. A 4-cell 4000 mAh lithium polymer battery used, which provide 14.8 V. Figure 2, image on left is thermal imaging camera and image on right is battery for camera and other small electric components in the drone. See brushless DC motor with propellers, ESC, and battery. U122K V60 motors 4 are being employed using for the drone. Outer runner brushless DC motor is used in this drone that houses the extremely durable magnets. The rounds per minute of the electric motor can easily be controlled by fluctuating the input current. The thrust produced by this motor is 19 kilograms. The motor is dust and waterproof, which makes them extremely durable. The propeller utilized is of length 30 inches and has a pitch of 10.5 inches 5. Also, the propellers are made from epoxy and carbon fiber, which make them exceptionally lightweight against the regular propellers. These propellers additionally have high weight to strength proportion. ESC utilized for this drone is Flame 80A6. The choice of ESC depends upon the motor and battery employed. Battery should match the power requirements of the motor and electric speed controller. We have employed 44,000 mAh lithium polymer battery with 44.4 V and 25C charge release rate. Flame 80A12's V2.0. D flight control board with RF transmitter and receiver. Use the flight controller board is referred as the brain of the drone. FCB regulates the motion and auto level controlling. There are different FCBs and vary from case to case. The FCB facilitates in communication, sensing and controlling the drone. One of the useful features of the FCB is, it receives the incoming signal and perform the commands depending on the input of the person controlling the drone. PHAWK 47 flight regulator can be utilized in the drone, which empowers an autopilot feature. Taranis X9D and SE2019-8 is used as transmitter and X8R9 is used as receiver for drone. Arduino with laser LiDAR and servo. Arduino microcontroller 10 is used here to control the laser LiDAR and servo motor attached to shooting mechanism. A laser LiDAR sensor is used for accurate range detection that helps in precise dropping and the shooting of fire suppressant balls. In this project the TF Mini LiDAR TOF, time of flight, sensor is used. It can measure a distance up to 1 m. This sensor will be interfaced with Arduino for further processing. TF Mini S LiDAR, TOF, laser range sensor, 1 m. Figure 5, image on the left is laser range finder and right is Arduino microcontroller. F frame of drone. The frame of the drone 11 will be having 6 motors and all the shooting mechanism will be mounted below the drone. The thermal camera will be in between the shooting mechanism and drone base. Calculation of thrust. Thrust delivered by one propeller and one motor equals 19,014 gm. Total thrust from 6 motors at 100% RPM equals 6 × 19,014. Equals 114,084 gram. Thrust to weight, T/W ratio, proportion is total thrust delivered divided by complete weight of drone. Equals 114,084/35708. Equals 3.19, 1. With T/W equals 3.19, the drone would have better mobility and an additional payload of 8 to 9 kilograms can be carried that makes the T/W ratio of 2.5, 1 and therefore is a good parameter for mobility. Battery drain time estimation. Battery will be utilized to supply power to 6 motors. Total current from battery equals 44,000 mAh. Current consumed by each motor at full RPM equals 41 A. For all motors, total current consumed equals 246 A. Time the battery last at 100% RPM equals 44,000 mAh/246 A. Equals 44 A x 60 min/246 A. Equals 10.7 minutes, approximate. However, we can utilize extra batteries to increase the flight time. Assuming we add 1 or 2 additional batteries, the flight time will have an increment to over 25 minutes, approximate. 3 working. Before the drone has 2 sections. 1 flying part. 2 shooting/dropping mechanism. The flying part, which includes the drone frame, motors, propellers, and other components, is common to other drones, but with high payload carrying capacity. A RF transmitter will transmit a signal which will be received by the receiver of the drone. Then, the signal goes to the FCB where it sends the received and processed signal to other electronic sensors as displayed in the figure 6. Also, FCB have inbuilt accelerometer and gyroscope sensor, which would be used to balance off the recoil force generated after shooting the ball and keep the drone stabilized mid-air. Figure 6, flow chart of drone flying working. The other feature which the drone employs is shooting and dropping fireball mechanism. This feature makes the drone useful in worse scenarios in which if a multi-story building is on fire and firefighters do not have access to go inside the building, this feature can help the firefighters to suppress the fire to some extent, so that they can make their way inside of the building. This mechanism consists of detecting the range, how far is the building from the drone, and then decide whether to drop or shoot the ball inside the building. The purposed mechanism has a range of 5 meters. The shooting/dropping mechanism comprises of spring and servo motor in a cylindrical housing. Servo motor is used to recoil the spring with the help of lever arm mechanism. When the current is cut off from the motor, the spring exerts its compressive force on the ball and the spring comes back to its equilibrium state. This spring force is used to shoot the ball out of the muzzle attached to the mechanism. The housing compartment stores the balls, which is designed to carry 4 balls at a time. Figure 7, side section view of 2D CAD model of shooting/dropping mechanism. Arduino microcontroller is used to control the servo motor used in the proposed method. The special Y design of the storing chamber maximizes its packing efficiency without making the drone bulky. Total of 4 balls are used in this mechanism. 3 balls are being stored in the storage container, making the drone symmetric and balanced. Figure 9, side view of CAD 2D shooting/dropping mechanism. Additionally, shooting mechanism also features a dropping mechanism which can be employed as per the requirement in case of roof of the structure or if an open field is on fire. To facilitate this feature, the spring is to be further recoiled, which opens the dropping hole as represented in the pictures above. The dropping hole has an offset of 20 mm to that of storage chamber hole. Calculations. The result obtained is the value of the spring constant, K, used in the shooting mechanism. Note, in all the calculations, the air resistance is not considered. 4 advantages. 1. This drone can be used for surveillance, hotspots, as well as to extinguish fire during fire accidents. 2. It can be used for post-accident damage analysis. 3. The high payload capacity of the drones makes it suitable to transport the medical supplies, in case the victims are trapped inside the building, and they need immediate medical assistance. 4. In case of fire accidents, the drone can be deployed immediately and serve as first responders against the traditional methods. 5. The drone provides flexibility to reach out to the difficult spots of the buildings, for example, balconies in high-rise buildings, roofs, windows etc., which are initially inaccessible for the firefighters. Future scope. Further enhancements can be made in this project in future. Employing a high-powered shooting mechanism can extend the shooting range of the drone. Furthermore, the design of storage compartment can be changed and designed to carry more payload at one time. The frame of the drone can also be improved by using more fire-resistant materials, such as glass fiber, carbon fiber etc., not only in the design and frame of drone but also the shooting mechanism, which makes the drone go much further close to fire in the emergency situations. More enhancements can be made to the drone, providing more stability during and after the shooting of balls. Machine learning algorithm can be integrated with cameras for real-time situation analysis, specifically finding the victims trapped inside. Conclusion. Nowadays, fire is one of the worst disasters not only in urban or rural life but also endanger our reserved forests. Every year lot of people lose their life due to fire disaster. This paper provides us with one of the alternatives to minimize the initial impact of the disaster, fire, and provides us with the opportunity to take the corrective actions in due time. When retrofitted with more advanced technologies, this drone can be utilized in not only in fire but other disasters management situations.